Hello, we shall take a new topic today, that is chemical kinetics. Previously we have discussed in last 15-16 videos the solution. That was the first unit of our 12th syllabus, and this is another unit, chemical kinetics. Okay, welcome to chemistry cure once again. So chemical kinetics means what? Chemical kinetics, see, kinesis, this term has been generated from the Greek word kinesis. Okay, kinesis is a Greek word which means what? Which means movement. Okay, movement. So movement means movement of what? Movement of, because in chemistry what is most important thing is chemical reactions. Okay, so in chemical reactions there is a term used, chemical kinetics, and especially the term rate. Okay, rate. And in case of rate, what we study about, the general person who doesn't know about chemistry, that person will understand rate means the distance traveled in specific time. That is what is called rate. Am I right? So rate of reaction means what? Rate of reaction, because chemical kinetics is what? This is a branch of chemistry which deals with the rate of reaction, the mechanism of reaction, and what? The factors affecting the mechanism or that reaction. What did I say? Chemical kinetics means what? This is a branch of chemistry which deals with rate of reaction, mechanism of reaction, and the factors affecting rate of reaction. That is what is called chemical kinetics. So the term rate of reaction. So rate of reactions means what? It doesn't mean that reaction will start from Kerala and it will reach to Rajasthan. That is not the case in case of a chemical reaction. Chemical reaction will take place within that same round bottom flask. Okay, and the round bottom flask will not even move. Only the magnet inside that round bottom flask will move. Okay, so the kinesis or movement doesn't mean that there will be a distance which be traveled by a reaction. Okay, it means what? Here the kinetics or movement means the progress of the reaction. The progress of the reaction means what? Progress of the reaction means the reactants are converted into product. So that is what the meaning of kinesis or movement here in chemistry, in a chemical reaction. Okay, movement of reaction means the conversion of reactant into product. That movement we are talking about. Okay, so how to define rate of reaction is the change in concentration with time. The general definition will be the change in concentration either for reactant or product with time is called rate of a reaction. Okay, so of course we will talk in detail. So another branch of our chemistry is thermodynamics. Okay, thermodynamics tells about the feasibility of a reaction. Feasibility of reaction means whether the reaction is a spontaneous one or non-spontaneous one, whether it is going to take place on behalf of itself, or we have to give some external force or some catalyst to start that reaction. Spontaneous reaction means the reactions which are taking place without any external force or without any external thing. And non-spontaneous means we have to start that reaction by some external force or maybe some catalyst or something like that. But the thermodynamics only will tell whether the reaction is spontaneous or non-spontaneous. That is the branch of chemistry which is called thermodynamics. Okay, but this this branch of chemistry, that is chemical kinetics. Chemical kinetics will tell us how fast the reaction is proceeding. Okay, how fast the reaction is proceeding. Thermodynamics tells us whether it is spontaneous or non-spontaneous. Okay, but chemical kinetics will tell us how fast it is happening, whether it is spontaneous or non-spontaneous. That is different thing, but how fast it is happening means it is taking fractions of seconds or minutes or hours or days to complete. Okay, so that is what is dealing in case of chemical kinetics. So most important thing in chemical kinetics is rate of reaction, and rate of reaction is what? The change in concentration either of product or reactant with time is called rate of reaction. On the basis of rate of reaction, we can even classify our chemical reactions into three major categories. Okay, the category first which deals with very fast reaction. Okay, first one is very fast reaction. Very fast reaction means these are the reactions which completes within fraction of a second. Okay, reactant convert into product within fraction of a time. Okay, fraction of second. Okay, so such type of reactions are called very fast reaction. Okay, very fast reaction. Say like if you are taking sodium and putting it into water. Okay, this is very fast reaction, and even sometime maybe explosive reaction, but you will get NaOH plus hydrogen gas plus heat. Okay, so this reaction is very fast reaction. Okay, you can balance it, and of course 2. So this is a kind of very fast reaction, category first. Very fast reaction sometimes may be termed as explosive reaction. Explosive reactions are also very fast reaction, and these are the reactions which are generally ionic reactions. Ionic reactions means there is no true chemical covalent bond between the atoms. There is just electrostatic force of attraction between the ions. So these are the reactions whose rate also cannot be determined. Explosive reactions, okay, the rate of explosive reactions cannot be determined easily because they take even less than fraction of time, okay, fraction of second. So the second category of reaction is very slow reactions. So very slow reaction means these are the reactions which takes years or months to complete or to get the final product. Okay, in such type of reaction we can exemplify by like rusting of iron. Rusting of iron. Okay, this is a very slow reaction, and rate of these reactions is not that much significant for us because these are the reactions which are not important industrially. Okay, very slow reactions. Okay, like weathering of rocks, that is also another example of very slow reaction. Okay, rate do not have any physical significance for this type of reaction. So that is second category of reaction. Third one is moderately slow. Moderately slow reactions are those reactions whose rate of reaction is in between category first and second. Okay, so rate of reactions of such type of reactions is like in hours or maybe one day or something like that. Like inversion of cane sugar. Inversion of cane sugar. Cane sugar means what? Sucrose. Sucrose if you are taking like what 12O H22 and O11. This is what the sucrose, cane sugar. Okay, so if you will hydrolyze it with H2O, okay, if you will hydrolyze with H2O, then what we will get? We will get we will get like C6H12O6 plus this is say glucose and C6H12O6. Okay, this is another one, fructose. Okay, so this is what the inversion of cane sugar. Inversion of cane sugar means that optical rotation is just inverted during this reaction. So that is a different topic we will discuss later. So this is a moderately slow reaction. Okay, and even hydrolysis of starch, if you will hydrolyze starch, then also you will get maltose. Okay, so in the presence of maltase enzyme, if we will hydrolyze starch, we will get a maltose. So that is also another kind of a very moderately slow reactions. So on the basis of rate of reaction, we can classify chemical reaction into three categories: very fast, very slow and moderately slow. Is it okay? Yes. So now let us see, again we are coming to rate of reaction. Rate of reactions, one general definition like we have given is the change in concentration either of reactant or product with time is called rate of reaction. Rate of reaction may be defined in terms of reactant, in terms of product, okay, and in a general way as well. So if we want to define rate of reaction in terms of reactant, then what we will say, the decrease in concentration of any one of the reactant with time. What we shall say is decrease in concentration of any one of the reactant with the time. That is what is called rate of reaction, of course. Okay. And another definition in terms of product, if we want to give, that will be the increase in concentration of any one of the product with the time. That is also called a rate of reaction. So how can we write rate of reaction is like rate of reaction, that is of course R. Okay, R will be equal to change in concentration of reactant or product with the change in concentration of reactant or product divided by what? Time taken. How much time is taken during this change? So this is rate of reaction. Another definition, increase or decrease in concentration of any one of the reactant. What we can write? Decrease in concentration of any one of the reactant upon time taken. Am I right? What did I say? Rate R is equal to decrease in concentration of any one of the reactant upon what? Time taken in this decrement. How much time is taken in this decrement? Or what we can write? The increase in concentration of any one of the product with the product and upon time taken. Okay, with time, if we are saying, that is definition. If we want to write mathematically, then this is how we can write rate of reaction. Now let us take a general reaction and express its rate. How we can express the rate of a general reaction and general reaction of type, a very simple stoichiometry. Okay, very simple stoichiometry. Stoichiometry is what we have discussed previous year in, of course, in equilibrium chapter. So if we are saying we are having A plus B, two reactants are there and they are converting into C plus D. This is the reaction having simplest stoichiometry. Simplest stoichiometry means 1 mole of A, 1 mole of B, 1 mole of C, 1 mole of T. Okay. So the rate of this reaction can be expressed like how delta A. Delta A means change in concentration of A upon delta T, time taken or change in time means T1 to T2 or T0 to T1, whatever the case is. So, but minus rate R is equal to minus delta A upon delta T. It means what? Delta A means the change in concentration. If we are putting this A or B or C or D in square bracket, it means the concentration of that reactant or product. Okay, square bracket means the concentration. So change in the concentration of A, change in concentration means there will be decrease in the concentration of A, and delta T means change in time, means how much time is taken to change this concentration. Okay, since the concentration of A is decreasing, that is why the minus sign. The minus sign here means what? There is decrease in concentration of A. Okay, means the final concentration, like say A1 is the initial concentration, and then A2 is final concentration. Okay, so A2 will be less than A1. A2 will be less than A1. Then how to calculate change? A2 minus A1. A2 minus A1. Okay, since we will get a minus value from here, okay, but rate cannot be in minus, hence the minus value if we will get from this this calculation, and outside if it is minus, then minus and minus will be plus, so we will get the value of R as positive value. That is why this minus has been taken. Minus has been taken means there is decrease in concentration of A is equal to what? Minus delta B upon delta T. It means the concentration of B is also decreasing with the time. Okay, decreasing with the time is equal to what? Is equal to delta C upon delta T, of course plus, because the concentration of C is increasing. Okay, C increasing, it means final value of the concentration of C will be higher. So the final value minus initial value, it will be of course a positive value. So the positive sign is already there, so rate will be a positive one. Okay, so that is why is equal to plus delta D upon delta T. So this is how we can express the rate of reaction in terms of any one of the reactant, any one of the product. Minus sign means there is decrease in concentration of reactant, plus sign means there is an increase in the concentration of a product. Am I right? Yes. Now if we are taking a reaction in which the stoichiometry of reaction is not the simplest one. Okay, stoichiometry means what? The number of moles of product and reactant in a balanced chemical equation. In a balanced chemical equation, so that numerical value of reactant and product moles is called its stoichiometry. The stoichiometry of reaction. Say stoichiometry of reaction is N1A means N1 moles of A plus N2B means N2 moles of B reacting with A, then we are getting N3A plus N4D, N3C plus N4D. So these N1, N2, N3, N4, these are the stoichiometry of this reaction. Okay, this will be a whole number, of course, whole number. Okay, not whole number, whole number means it will not be 0, okay, other than 0 if it is there. So it will not be fractional one, okay. So if it is n1, n2, n3, n4, then how to express rate of reaction will be R will be equal to what? 1 by minus 1 by n1, the same thing, delta A upon delta T. So if stoichiometry is there, we will take it like 1 by n1 will be equal to what? Minus 1 by n2 delta B, concentration of B upon delta T will be equal to 1 by n3, of course, plus delta concentration of C upon delta T plus will be equal to what? 1 by n4 delta concentration of D upon delta T. So this is how we can express if we are having the stoichiometric value other than 1, okay. If say if it is like 2, then 1 by 2 delta A upon delta T will be equal to rate of reaction. If we want to take any example, then see we can take an example as well. Like if you are having this reaction, say we have written right now like 2Na plus 2H2O is equal to what? Is equal to 2NaOH plus H2. Okay, this is what the reaction was. So now if you want to put it here in this formula, then how what will be the rate of this reaction will be like R will be equal to 1 by 2, R will be equal to 1 by 2 because N1 is 2 here, okay. So minus of course and concentration of Na upon delta T, okay, is equal to minus like 1 by 2 again delta H2O upon delta T will be equal to again 1 by 2 delta concentration of NaOH upon delta T will be equal to delta concentration of H2 upon delta T. So this is how we can express like if we are having stoichiometry of a particular reaction, okay. So this is how the rate of reaction can be expressed. Now let us see the unit of a rate of reaction, okay, because the general unit of rate is what? Meter per second or something like that, am I right? But for rate of reaction, what is the unit? We know that rate is equal to what? Concentration or change in concentration upon change in time. That is what we are having in the formula. In all the formula, this is what we are having. So concentration means generally concentration is expressed in terms of molarity. In terms of molarity means mole liter inverse. The unit of molarity, what? Mole liter inverse. Am I right? So what we can write here is mole liter inverse. Okay. And time will be expressed in SI, that is second. So second will go here like, or it may be minute inverse or like hours in hour inverse may be there, but generally it will be in seconds. So this will go up inverse. So the unit of rate of reaction will be mole liter inverse second inverse. This is the unit of rate of reaction. So this was a very general explanation of what chemical kinetics is, what is rate of reaction, how we can classify the reaction on the basis of rate of reaction, how can we express rate of reaction in terms of either reactant or product, and if we are having some stoichiometric values in the balanced chemical equation, then how to express the rate of a reaction. So that is what we have discussed today. So later in the next video, what we will take this rate a little further, a little ahead, and we will discuss instantaneous rate, average rate, rate constant, rate law. These are the things which we are going to discuss in the next video. For the day it is sufficient, I feel. Thank you very much for watching. Happy chemistry. Take care.